Hello everyone and welcome back. My name is Mr. Cobalt, and in this video I'm going to go over how to calculate the standard entropy change for a reaction. I've got a couple of practice problems for you. So let's get into this. So, when you're trying to find the standard entropy change for a reaction, one way to do it is to use the equation that I'm going to write on the board. So here, the standard entropy change of a reaction is equal to the sum of the n, right? So n is like the number, what do you call it? The coefficients in front of the numbers. So the n multiplied by the entropy that you find for products, standard entropy for the products, right? So products minus the same thing. So the sum of all of the entropies of the reactants multiplied by their coefficients. So n times the standard entropy of reactants. And these standard entropies are entropies that you look up on a table, right? So here behind me, I have a table of entropies. So I've got the substances used in the reactions, and here are the entropies. Oh, that should be entropies, not standard entropies. So these are the entropies that you would look up on a table. So we're going to use those. So then here's the equation we're going to use. And so all we're going to do is we're going to look at the products. We're going to take the entropy, the standard entropy of each product, and multiply by its respective coefficient, the number of moles, and that's the coefficient. So then here, this is going to be equal to, so we'll take our product, so NO. So NO has a 4, so it's going to be 4 times whatever the standard entropy of NO is, and we go to our table here, and NO is 210.8, so it's going to be 210.8 joules per Kelvin. And then we're going to add to that. Sum means you're adding them together. So this symbol is sigma, capital sigma, and that means sum. That means adding together. So we're going to add together all the products first. So let's put a square bracket around this. So we're going to multiply these together, and then we're going to add water. So water is going to be 6 times, because that's the n, the coefficient for water, 6 times. And then we look at the delta S for water. And in this case, it's water vapor. So we look up the one for water vapor, and it's 188.8. So we're going to multiply that by 188.8 joules per Kelvin. And that is all of the products. And then we subtract out the reactants. So we subtract out, put our negative, and we're going to put a bracket, a square bracket there. And then we do the same thing for the reactants. So we have 4NH3. So that's going to be 4 times. And then for NH3, it's 192.8. So we multiply 192.8 joules per Kelvin. And then we're going to add to that our oxygen. So we have 5. So we're going to multiply that by 5. And we're going to multiply that by the oxygen here. So we look at our table, 205.2. And that's joules per Kelvin. And then we close that out with a square bracket. So we're adding together the, the, the products, and we're subtracting out the total of the reactants. So then we calculate this out. What did I get? I got 19,760. So multiplying these, adding them together, this equals 19,000. What do I have? 19,760. And that's joules per Kelvin. And we're going to subtract this whole thing. So I calculated, what did I calculate? 1,797. 1,797.2. And that's joules per Kelvin. And so now just subtract those. And when we subtract those, I got 1,700 and let's see, hold on a second. Let me double check. Nope, sorry. This is not 19,000. This is 1,900. So 1,976.0. Subtract that out, and I get what I get. 1,700. 1,788. Yep. 88 joules per Kelvin. And so that, ladies and gentlemen, is the standard entropy change for this particular reaction. So, and then for this one, we do the exact same thing, use the same equation. So I'll just leave it up here. So delta S, the standard change in entropy, is equal to, and then we're going to do products minus reactants. So products first. So put my square bracket here. So I have 2 times that of water. Water is the same. It's gaseous water. So 188.8. So 188.8 joules per Kelvin plus, and then my next product, SO2, I got 2 of those. So it's 2 times SO2. Here I have SO2, 248.2. So 248.2 joules per Kelvin. And then that's it for my products. And then I'm going to subtract out the reactants. So I'll put my square bracket. And again, so I have 1 H2S. So I'm going to just put a 1 there just to be complete. And I'm going to multiply that by that for the H2S. So H2S is 205.8. So that's 205.8 joules per Kelvin. Okay, and then finally oxygen again. So I have 3 of those. I'm going to add that. So 3 times, and then O2, 205.2. So I'm going to put 205.2 joules per Kelvin. And then close it off with the square bracket. And now I just do the calculations. So when I calculate these together, I get 874. So that's going to be equal to 874 joules per, let's see, per Kelvin. And then I do the next calculation. And that's going to be, let's see here. That's going to be 1,000 and 27.2. Let me double check that. Okay, I see my mistake. So here, my equation's not balanced. I forgot the 2 there. So now it's balanced. And so if that's a 2 there, then I need to change my 2 there. All right, so now when I do the calculation, I get here a 1,027.2. So we're going to subtract out 1,027.2 joules. And the other thing I forgot was the moles. So this should be joules per mole Kelvin, joules per mole Kelvin. So let me fix it here. So the standard S is going to be in joules per mole Kelvin. So let me erase this. That'll be the easier way to fix it. And so here, this would be moles Kelvin on the bottom. So this is moles Kelvin. This is moles Kelvin. Moles Kelvin, moles Kelvin. And so then this should be joules per mole Kelvin, which is the proper unit for your delta S. Sorry about that. Moles Kelvin. Okay, so same thing here, moles Kelvin, moles Kelvin, moles Kelvin, moles Kelvin. And here we have moles Kelvin. And this will be joules per mole Kelvin. And then when we subtract this out, we get what I get a negative 153.2 joules per mole Kelvin. So that is the standard entropy change for this reaction. And so I hope this is helpful. Sorry about the mistake, but hopefully it didn't throw you off too much. If you enjoyed this video, if you learned a lot from this video or anything from this video, then by all means, please like the video, share the video with your friends, hit that like button over there. Also, don't forget to subscribe to my channel, hit that notification bell, and when you do, click all so you can be notified by all the videos I put out. And finally, put a comment down below. Let me know what you think. Ask me questions. I'd love to hear from you. Thanks for joining me, and have a great day.